With a significant background in research, aerospace innovation, as well as managing relationships between manufacturers, suppliers, and researchers, our next speaker knows what it takes to turn research into practice. He's helped grow the University of Sheffield Advanced Manufacturing and Research Centre, and he now heads our very own Advanced Manufacturing Research facility here in Western Sydney. To give us the lowdown on the facility, what it is, what it does, and how we can all take advantage of it, because he loves it when you take advantage of it, please welcome the Executive Director of the AMRF, Ben Kitcher! Yeah, woo! Crowd goes wild.
Thank you very much, Warwick. Wow, okay, that's probably the biggest intro I've ever had, and the energy is going to be hard to keep up, I'll be honest, because that's something else. We will do our level best, though. We'll do our level best. Today I'm going to share some more information with you on the AMRF, some of the progress, where we've got to, some of the fundamentals for those who haven't seen what we're doing before to understand what it is we're doing with the AMRF, and a little bit more detail in some of a little bit more detail in terms of some of the processes, practices, and services that will be on offer through the AMRF incredibly shortly when we open the doors. Okay, so kicking off, where are we? We're in the Western Parkland city. So this is the 8 council areas to the west of Sydney, making up 65% of Greater Sydney's area. It's a gigantic area, but also it's huge in terms of manufacturing output. You will be familiar with this in the industry. It's also an area of huge growth and a growing population, and the opportunity for businesses to expand, particularly in advanced manufacturing, particularly with large migrant workforces coming to New South Wales and into the Western Parkland city. There is a great opportunity for business growth here. We're centred around the Aerotropolis, around the new airport, and the AMRF is one program within the Western Parkland City Authority's broader responsibilities. They include the construction of Bradfield City Centre next to the airport, also programs such as the Industry Skills Accelerator, which I'll touch on in a short while, but right at the heart of it, and I'm proud to say the first thing kicking off here, is the Advanced Manufacturing Research Facility. Now, New South Wales Government has invested incredibly heavily into the project as a whole, but also we can account for more than $300 million of investment into advanced manufacturing technologies at the centre of this place. And when I show you some images in a second, I hope you'll share my excitement when you can see a new city being built and the very first things going in are actually manufacturing. I think it's wild and incredibly exciting. So a very quick backdrop to the AMRF. This thing is being delivered in 2 stages. The first stage, called Stage 1, inventively for now, is due this year. So you'll see a big presence from the AMRF at AMW this week. This has been a long journey to get to this point, but we're all incredibly excited to open this facility, to start operations this year. And that will be in our 3,500 square metre facility, which I'll give an update on in a second. The second stage of the AMRF will come in 2026. Now, this part of the program was funded in 2022. It is a much larger facility. It's a much more complex facility. And you'll also see there, in terms of the focus of the facility in microelectronics, it's also incredibly ambitious. And what we're looking to do here is to build on research strengths, build on emerging trends, future opportunities for New South Wales in manufacturing, in the industrialisation, the technologies that are invented here, but actually turning that into production and product being shipped out of New South Wales. So you can see the design of the facility there. This facility, I expect, will be going into construction either at the end of this year or the start of next year. It will be a big complex construction project, and we'll be looking to open that one in 2026. One thing to note on here as well, and the subject of AMRF Stage 2 is probably for another presentation another day, but from my point of view, there is a great synergy between the capabilities that we'll look at in some more detail. I think is probably reflecting off my head, I apologize. So the capabilities in the 2 facilities, I think, are... All right, we'll try that. Are incredibly complementary. When you look at areas that have huge amounts of semiconductor product output, electronics output, you will also see a very strong industry, particularly in the machining of parts, fabrication of parts, and additive manufacturing more recently. And I think these two technical focus areas will be very, very complementary, and we'll actually see with the success of Facility 2, even more success with the technologies that are being focused on in Facility 1. So a quick status update on where we are with the project today. Here's our first facility in the wood and the glass on site. This was just a couple of weeks ago. The construction is progressing now incredibly quickly. You can walk into the building. Walking around the outside does not do the place justice. This as a center for manufacturing technology is a landmark for our manufacturing industry in Western Sydney. I don't think can be underestimated, and I want everyone here to come and participate, to see, to meet, connect, and be a participant, be part of the family in this center. So if we take a look at this center and the progress we're making from the air, this is what we look like today. You can see the metro under construction for Bradfield City Centre, the station box there. There are some TBMs somewhere between the airport and this site at the moment. We're expecting those to pop out in a couple of months' time. And of course you can see the first building now that's getting its solar roof installed, and the first components of the civil works around this building. These are the first roads ever going into the Bradfield City Centre. As we get towards the end of the year, you'll see the completion of that building, the green roof installation, the clearing out of the construction work for that particular building, and of course we will also see some progression with the metro site as well. This is where things get really exciting for me. So if we fast forward 2 years from that point, so to the end of 2026, this is what Best Place is going to look like. And this is what we're going to be working in Bradfield. And this is the point at which I say, share my excitement. This is a new city that is being built. Manufacturing is right at the very center of it. And I think manufacturing has a role to play in the jobs that are created, not just on the shop floor, not just in the engineering services, but for me, everything from recruitment, legal services, financial services, being targeted at the manufacturing sector is an opportunity here. Sorry, I should also mention as well, of course, Superlot 1 and nearing completion by the end of the decade. You may have noticed, but last week the authority released an EOI for the construction market to come and propose their solutions for Superlot 1. And that's been met with a great response. I will share that manufacturing and the market has been briefed prior to this release on the work that's been done through the AMRF, and the industry, the construction industry, can very clearly see the value in having manufacturing as an anchor industry in this place. It makes sense to them. It's very much an additional value, and we're expecting a great response. By the end of 2030, we'll see the build out of that Superlot, and that will include commercial space for businesses, residential, and I believe I'm right in saying it's 10,000 dwellings with a 30% affordable housing content. So really great outcomes for a place, but also for the AMRF and supporting the development of this place. So that's where we are. We're now just going to have a look at what the AMRF is being established for, what it's here to do, and then, as I say, we'll move into a more detailed look at some of the services and processes that will be run. So what is the purpose of the AMRF? Why are we doing this? What's it going to do? So as a very headline level, what we want to do is create the accessible and lasting opportunities afforded by manufacturing and the industry of manufacturing by addressing the world's manufacturing challenges with local solutions. So I'm always keen to point out here that some of the manufacturing challenges that we face as an industry are not unique to Western Sydney, to New South Wales, to Australia. Actually, some of these challenges are global. The opportunity we have is to implement solutions here, but also to create those solutions and export solutions where possible. So I'm really excited about that as a long-term objective. In terms of the actual objectives, we can break these down into 4 key areas. Number one, and probably the most obvious for an organization which will have the skills, tools, machines, resources available to pilot and translate these manufacturing methods, is deliver advanced manufacturing solutions. And we'll go into that in a short while in some detail. The next is to upskill manufacturing staff to foster the technology adoption. Of course, what we want is for these solutions, for the manufacturing methods to be taken and ownership to be taken by business so that they can own those solutions, but also adapt them, translate them over time. This is to provide an opportunity for business to open the box, to control the manufacturing processes in-house, so that when change happens, which it invariably does, that change can be coped with and adapted and hopefully optimized by businesses themselves. Next up is translating early stage R&D to scale production. And this really goes to the heart of AMRF Facility 2. There is a huge opportunity for some of the great research outcomes that comes out of our laboratories to not just commercialize the products and technologies which are coming out of those labs, but actually to industrialize them here too. So that's an economic opportunity for us all, but I'd also argue that there are other follow-on benefits as well as the financial or economic, such as speed to market, the ability to control and secure our processes, are all bundled into that ability to industrialize technology here in New South Wales. And then finally is fostering our networking and partnerships. Now, this is my first time at AMW in 2024. I am blown away already. I think we're an hour or so in by the level of activity, the commitment by businesses to being here. I think it's absolutely awesome. What we want to do is to provide an ongoing ability for manufacturers to connect in New South Wales around the AMRF. We think it's a great opportunity, particularly for people to meet in a relevant environment. So when you're having, when you're making connections, when you're having your meetings, to actually see the solutions and be able to talk around those solutions as you're meeting is a great opportunity. So in terms of stage 1 capabilities, what have we been preparing over the past months? Well, the 8 boxes on screen here don't really do justice to the level of detail and investment that's gone into the capabilities in the AMRF. But firstly, you will see some of those capabilities at the show here today. So if you come to the New South Wales and Invest New South Wales stands, you'll see AMRF, but you'll also see our DMG Mori NT4250. That's obviously one of the capabilities that will cover precision machining in the AMRF. If you head to the Benson stand today, you will also see the Additive Industries G2 machine, which will be later in the year transferred into the AMRF. Now there's a range of other equipment which I can't cover today, which is going into here, but one of the key things I'd like you to take away is our objective with this facility is to offer the end-to-end capability under one roof to solve manufacturing problems. This isn't an isolated capability and machine tool. We want to work with business all the way from the first characterization of either a problem or an opportunity through the development of the solution, the demonstration and making that solution robust, all the way through its qualification at the far end as well. So qualification leading into certification for that solution. The idea being that we make it much faster and much easier for individuals and businesses to progress their ideas, progress their problems through the facility so they can be implemented more quickly they can sorry, I'm having hand gestures made of me. I've been distracted. Speak louder. Okay, I will speak louder. I apologize. So those solutions can be taken into factories more quickly, and ultimately, businesses can actually get to the point where they're making money back and seeing a return on the investment that they're making in these technologies. So where do we sit in the development cycle? How does this thing relate to other organizations that are working in the research space? Well, one area that we're very keen to point out that we are strictly focused on is in MRL development, manufacturing readiness levels, as opposed to technology readiness levels. And the MRF is designed to support businesses here through from MRL1, so that's proof of concept, first off, I might even say an unoptimized manufacturing process that enables the latter stages of a technology development all the way through to MRL6. So there are various definitions for our MRL levels, but what you will commonly see at MRL6 is the demonstration of a manufacturing process in a production-relevant environment on production tools. And there is a reason why at the AMRF we're investing in production tools, is so that we can help manufacturers hit that milestone. By hitting that milestone in the AMRF, we believe there's a great opportunity for manufacturers to show the robustness of their processes and actually move forwards into the investment on their own shop floor with much less risk and a much greater appetite for that investment over time. Now, of course, it doesn't stop there. I do see there is an opportunity for the work of the AMRF to work in a translation onto manufacturing floors. So if we look at a composites development process, you wouldn't simply stop the process at MRL6 and then say, right, that's it, we're done. There is the opportunity then for the teams of the AMRF in their branded shirts to come to factories and work with you in the implementation on the shop floor. In terms of the services, we grouped this very broadly into the manufacturing processes. There is opportunity where no other capability exists to look at some prototype parts, people and workforce development, and then partnerships around the AMRF as well. But I would say it's incredibly hard with something like the AMRF to really put brackets around the types of services that will be offered. No two problems that will be brought to the AMRF will be the same, and I'm very, very confident in that. And so to be absolutely definitive at this stage with the services that are offered, I think is very difficult. What I would encourage you to do is, despite us having these 4 categories, if you do have a challenge you would like to talk about, an issue you'd like to address, just come talk to us, because these can be absolutely flexible in how we work. But another aspect that I think can be flexible, but we need to be much more detailed on, is the ecosystem, the types of organizations that work in that ecosystem. So first up, and you'll see at the top of this diagram, there's the industrial end users and the manufacturers themselves. Now, these two groups are the focus of the AMRF. Its impact in these types of organizations that the AMRF has been set up to create. And we'll have a look at in a second at what that means. Now, just as important, but more as an enabling function, we also see our government collaborators, education providers, research institutions, and technology providers. Without any of them, we lose an opportunity to create more value. And the connectivity between those partners, I think, is absolutely key. So particularly, as a New South Wales government organization, I think our opportunity to advocate for manufacturing industry, but also translate policy into results, I think is a fantastic opportunity. And likewise, working with education partners and research institutions, we have a great opportunity to work on that translational step locally with manufacturers into the shop floor. Now, for the final part of the presentation, I'm going to take one example, and this is somewhere we've not yet gone with anything we've spoken about with the AMRF. So you may have seen some of my previous slides before, but this is now, as we're nearing the opening of the AMRF, we've got the opportunity to start digging into what a project and what a process might look like, what some of the outcomes might be. And this is a look at a fraction of the work that will be going on in the AMRF. But what I'm hoping is it will give you some inspiration to think about actually how you might use the AMRF in alternative technology areas, what you would like to see, and come back to us with those proposals. It's all very welcome. So for this example, I've chosen to look at the optimization of a machining process. I've chosen that because I'm a machinist by trade. It's what I know, and I don't want to embarrass myself by trying to talk about automation in front of a crowd. So we're having a look at this optimization. We'll have a look at some of the different approaches the MRF will take, and some of the outcomes. So when we start a project looking at an optimization, I think it's important for us to think about how do we build the fundamentals of a productive process from day one, and then what are the components that sit on top of that that lead to a genuinely competitive and world-class process. So this hierarchy is not definitive, but I think it's a really good starting point for us to begin to understand how to optimize a process. So we begin right at the very start with a system geometric conformance check, i.e. is your machine square and true? And i.e. if it's not, you're going to very much struggle to produce a conforming part out of it. We then move on to system dynamic performance, so looking at the vibration response and modal analysis of a machine tool, through work holding and stock condition optimization, into tooling and parameters and the parameter selection. Those then feed into the programming methodology that we'll use. We'll then look at in-process automation. So how do we use typically the on-machine probe to automate our processes? And finally, at the very tip of this pyramid, and I'd argue still very much at the cutting edge and not necessarily a common thing found in industry today, is adaptive systems. So how can we begin to use sensors in our machine tools to adapt a process as it varies from part to part? Just having a look at this pyramid, my first comment or expectation would be that the bulk of us tend to work in the central section of this hierarchy. So when we look at the optimization of a process, we tend to work up from work holding and stock condition and optimization through tooling and parameters into programs. In terms of bang for buck, assuming that the fundamentals of our system are correct, there's a great opportunity there to actually improve our productivity. But for today, what I'm going to do is just take a little bit of a zoom in on the tooling and parameter optimization component of this pyramid, and have a look and see what the difference will be between business as usual and the AMRF. So here we've got two different process flows. One is a typical process flow that I know I've done in the past. I've done it relatively recently, in fact. And the other one is how we would approach a similar problem with the tools and resources of the AMRF to produce a different outcome. So looking at that first process, the typical process, and this is a manufacturing engineer being tasked with taking some process time out of a particular product on a machine tool. Where do you start and what do you do? Well, typically you'll do your research on the various tooling options that are available to you. That often includes a huge amount of liaising with suppliers, but probably trawling catalogs and websites and down selecting the tools that make sense for you. You'll order those tools in, bring them in, determine the window of parameters that you can use based on the manufacturer's technical data, and then look to do some optimization around that, probably turning up feed and speed on the machine as you go. When you get to the end of that trial, once you have a cut that you are happy with, once you have a process and productivity you're happy with, you'll then say, right, this is my preferred process, I will take it forward, and I'll subsequently base the programs that I create on that tooling and parameter set that I've just discovered on my machine tool. Now, my argument would be that is absolutely fine and valid for singular production, for small batch production, if you have a one-off job to complete. But every time we don't actually take this further and explore the limits of productivity, we're leaving performance on the table. And it's actually that performance that will ultimately determine whether we're competitive or not in the marketplace, and that's what we need to be chasing down. So the process, and this is an example process that could be run at the AMRF, not every stage is necessary. There may be more that we put in here. But just to have a look at a headline level, what could be done? So the first thing is access to the suppliers, the vendors of the tooling. I would expect the teams in the AMRF to have a more recent knowledge and proximity to the tooling releases than perhaps is common across businesses, just because these people will be exposed to it day in, day out. So the ability to look broader, but also understand exactly where to look and save time there is an opportunity. The next step is modeling. There is an opportunity to apply some modeling up front to our tooling trials, to be able to narrow down the process window that we want to be targeting. So for example, if we're working with a particularly stringy material, a stainless material of some description, we may wish to model to make sure we've got good chip breaking in that process. On the back of those indicative parameters, we can work out our factorial design of experiments and then run into the experiments. Now, key point here, with the capabilities under the roof of the AMRF, we'll actually be able to run those experiments offline. So we won't be using production machines' capacity to run those trials. It can happen in parallel. And for time-crunched manufacturers, I think that is a great benefit just in itself. Now, as we're going through the tooling trials, we're not just listening to the cut, we're not just taking the tool out at the end of its pass to have a look and see if it looks worn or not. There will be the opportunity to do confocal microscopy, to do some digital microscopy, to look at the condition of the tool, to understand the wear mechanism that's occurring with that tool, and to really understand whether or not that's detrimental to the component we're manufacturing, or indeed the life of the tool that we expect. Now, at the end of the process, we'll record the KPIs. That will give us one half of the equation. The next part of the equation is understanding the part that's being manufactured. So let's say, for example, we've machined 100 rings in a turning tool trial. Those rings can then go and be inspected for geometry and form, and we can look for any kind of indication that although we have a high-performing tool, we don't actually have a conforming part coming out at the end. And once we've checked that physical data, we can then move into microscopy. So we can do cut-ups of those components. We can understand if we're producing a white layer, if we've got grain deformation, surface plucking on that component. And that data will then feed into, in the future, potentially, the certification of that process for industries such as aerospace or medical applications. So when we get to the end of that, the opportunity is to have a set of tools that have got all the data sat behind them, say this is a compliant process, but also we've accessed a window of productivity that maybe we would have missed had we not gone through this structured process. I do, however, I recognize that when we look at it in this way, when we look at it on a page, it could almost seem a little bit academic in terms of its endeavor. But I would say the results speak for themselves in terms of the impact this can have on a manufacturing business. So take, for example, I've set a target here of 25% reduction in a cycle time through tooling optimization. In my experience, that's relatively low, and I'll talk through an example in a second, but 25% reduction, single shift, single machine tool, that's 360 hours of additional machine time availability per year. So if we think about the opportunity of optimizing a process that is on a long-running product to series production product, the opportunity is actually to create more capacity in your factory that then has a higher profitability in itself. The certification of the process and the data that comes out of the process can lead to greater qualification of it and application into those industries such as aerospace and medical. Machine availability we touched on previously, so doing these trials offline, investing the time offline and then transferring them in is an opportunity again to save more time. I'll mention impartiality, so the ability of the AMRF to perform these tools, provide you with the data and provide the productivity gains without trying to sell you a tool at the same time. Now I do think actually from a tooling vendor's point of view there is a huge benefit here too, and that is proving unequivocally the performance of your product. So in my experience, I've seen a huge degree of participation in these types of trials from tooling vendors because they want to be able to demonstrate when they make a claim about the performance of their product, it can be demonstrated in an impartial environment like the AMRF. And finally, competitiveness. By going to these lengths and demonstrating the dedication a business has to the quality and productivity, there is a great opportunity to improve competitiveness and position the business as doing that work in the market. Now, a very quick practical example to wrap up. Going back to this pyramid, I'll give you one of a project from 2016. This was for a large aero engine component, a shaft for an aero engine, and that had a top-to-bottom workover. So all the way from checking the machine geometries, in the factory, through the tooling optimization, new work holding, changing from chucks to collet mandrels on the machine tool, etc. The overall result for that factory was a 50% or 56% reduction in cycle time. Now that was the in-cut cycle time. On top of that, there was a greater than 90% reduction in operator interventions. Now that came predominantly through the use of in-process automation, removing swarf clearances because you were chipping the swarf correctly, and also using the probe to take measurements and perform measure cuts rather than relying on the use of a vernier or micrometer. So 90% was additional on top of that. I would also say those operator intervention reductions not only are a time saving, but also they give you certainty in terms of the scheduling as you're moving parts through the factory. So they received another benefit there. And then finally, there was an overall reduction in 25% on the tooling bill per part. So fantastic opportunity. It was a very long-running part. The original process had been in manufacture since 1999, and I can guarantee those same processes are running today, making those parts. But those savings just continue and compound. So I'd argue for these long-running parts, there's a great opportunity for us here to realize greater productivity. So just to recap, that's one example, one detailed example that I wanted to run into to show you the type of work that will be going on in the AMRF in the coming months. There are, of course, many other technical areas, additive manufacturing, composites, automation, etc., that we will be going into. And I'd love to share the processes we'll be going into there at a future date. But this is really just a snapshot of the type of services that will be coming through. If you do have other types of challenges that you would like to look at and see addressed, we're on the New South Wales stand all week. We'll be here till Friday, but also you can find our contact details online, and we'd just love to take feedback because that's how we're going to make sure we provide the right capabilities and services. Now, as a final point here, I'd like to highlight the fact that our Industry Skills Accelerator is also enrolling for courses right now. So these courses are currently online, able to enroll. They will be followed up by further courses, and I encourage you to look at the ISA webpage on the WPCA website, where you'll find details of upcoming courses too, and also the opportunity or request to provide feedback on future course content and material and how you can be involved. So I'll finish there, leave the slide up. Thank you very much for your time and attention.
Thank you very much, Ben. Thank you.